Hi, my name is Joe Vasta, and in this video we are going to prove the Euler identity. Of course, you should have had a year of calculus, or otherwise this might not make sense. Let's start off by saying that I to the first is I, which we know is the square root of -1, but we'll just remind you that I to the first is I. I squared is -1, I cubed is -I, and I to the fourth is 1. We'll need that. The next thing we're going to look at is e to the ix. Now, if you've studied a whole year of calculus, you probably learned power series, and there's a power series representation for e to the x. You can look it up in your calculus book. What I'm going to do with that formula is everywhere there's an x, I'm going to replace it with an ix, I times x. And so the formula that we have is an infinite series. And, you know, e to the x has those factorials on the bottom, and it just keeps going forever. And we have an ix, I squared, x squared, etc. So the next thing that I'm going to do is I replace the I squared with a -1, and the I cubed, you see down at the bottom, with a -I, and the I to the fourth with a +1, and the I to the fifth, that actually equals I to the sixth, you know, really, because I to the sixth is I to the fourth times I squared. So an I squared is -1. And here's I to the seventh is -I, and I to the eighth is a +1. So if you take powers of I, you see that they go in cycles of 4. So hopefully you've seen that in an algebra class. And my next step that I'm going to do is I'm going to separate my terms that have i's in it and put them over here, and then put the terms without i's on this left side here. So you can see, like, here's 1, and then the next one that does not have an I is -x squared over 2 factorial, and then the next one that doesn't have an I is x to the fourth over 4 factorial. So it's every other term, and so those guys go there, and then the ones with the i's I put over here. Okay. My next step is to factor an I out of this part right here. And so that's what I'll do. So I factor the I out there. Now, if you've had a full year of calculus, you've learned the power series for e to the x, but there's also a power series for the sine of x and the cosine of x. And that's what we have here. These guys maybe look familiar to some of you, but can be replaced with their power series representations. So there's the cosine x, which is this guy right here. And then we have plus I, and then this right here is the sine x. We have that right there. And so there's the Euler formula. And the cool thing about the Euler formula is the following. If you let x equal pi, you get e to the I pi equals the cosine of pi, which is -1, plus I sine pi is 0. You get one of the most intriguing math formulas out there, e to the pi I equals -1. So we just proved that. I mean, you take an irrational number like e, raise it to another irrational number times the square root of -1. Lo and behold, you end up getting exactly -1. Hope you enjoyed this video.